What if I told you that right now, time is literally moving slower for astronauts on the International Space Station than it is for you? Not because of traffic or stress, but because of Einstein's crazy idea of space-time. In the next few minutes, I'm going to show you why time is actually the mysterious fourth dimension and how your phone's GPS would be completely useless without it. Stick around, this will blow your mind. Imagine the entire universe is a giant trampoline, a stretchable fabric. The fabric is made of four things: three directions of space, which is forward, backward, left, right, up and down, and one direction of time, which is from past to future. Together, this four-part system is called space-time. Einstein and Minkowski showed us that space and time are not two separate things. They are deeply connected like threads in the same cloth, bend one and the other bends two. Einstein proved time is relative in his special relativity theory in 1905. It slows down with speed and changes with gravity. But the revolutionary idea of time as the fourth dimension actually came from his former math professor Hermann Minkowski in 1908. Einstein hated this concept at first. Only later did he fully accept and use the 4D spacetime concept in his general relativity in 1915. Why time is the fourth dimension? Think about it. To tell someone exactly where you are in space, you need three numbers: length, width and height. But to tell them when you are, you need one more number, which is time. Here is the perfect example. If I invite you to a restaurant, I can just say it is on 3rd Street, which is length, at the 5th floor, which is height, near the north gate, which is the width. You would definitely show up, but at the wrong time and miss me completely. So I also have to say at 7 p.m., which is time. Without the time, the location is useless. That's why time is officially the fourth dimension. It is not some science fiction idea. It is how the universe actually works. Einstein illustrated this dramatic effect with his famous twin paradox thought experiment. Einstein said, time moves differently for different people depending on how fast they are moving or how close they are to gravity. This is known as time dilation and length contraction. Let's see time dilation. Time slows down when you are moving super fast or near heavy objects. Let's see length contraction. Space itself shrinks for anything moving near light speed. Imagine you and your twin brother are exactly the same age right now. You stay here on the earth, living your normal everyday life. Your brother gets into the spaceship and travels at nearly the speed of light. When he comes back to earth, he has barely aged at all. While you have grown older, he is now younger than you, even though you are twins. This is called twin paradox, and it is 100% real according to Einstein's theory of relativity.
This is exactly what Christopher Nolan showed us in Interstellar. Cooper travels through space and returns much younger than his daughter, who has grown old. In another scene, Cooper and Dr. Brandt spend only few hours on Miller's planet, but because the planet orbits extremely close to a massive black hole, its gravity is so intense that time moves much more slowly there. When they return to the Endurance spacecraft, Dr. Brandt is overwhelmed with emotion. That's because their colleague Romley has been waiting for them for 23 years, 4 months and 8 days. Both of these scenes are powerful examples of the effects of time dilation.
Fine, how do we know this is true? Let's take one sample day, 24 hours, to compare how much time difference happens due to Einstein's relativity. Let's move to the proof one: GPS satellites. Here is the part that actually affects your life every single day. GPS satellites orbit Earth at high speed, approximately 14,000 kilometers per hour. They move very fast, so as per the special relativity, clocks tick slower, slows down satellite clock by approximately 7 microseconds per day. And they orbit at high altitudes, 20,200 kilometers above the Earth. They are further from Earth's gravity, so as per general relativity, clocks tick faster. Speeds up clock approximately 45 microseconds per day. So the net effect, satellite clock ticks approximately 38 microseconds faster per day than Earth clocks. According to Einstein, their clock ticks slightly faster than clocks on the ground. If you don't correct this time difference, your Google Maps position would drift by 10 km per day, making the system useless. You would be lost in the middle of nowhere trying to find your favorite restaurant. Thankfully, engineers built Einstein's 4D space-time correction into every GPS signal. Let's move to the second proof, astronaut on International Space Station. Even normal space travel shows time ticks differently at high speed. Astronauts on the International Space Station orbit Earth at high speed, approximately 28,000 km per hour. They move very fast as per special relativity, clock tick slower. Slows down clocks on the ISS by 28 microseconds per day. And they orbit at high altitudes, 400 km above Earth. They are slightly further from Earth's gravity, so as per general relativity, clock ticks faster. Speeds up clock by 0.3 microseconds per day. So the net effect, clock on ISS ticks 27.7 microseconds slower per day than Earth clocks. So the result, they age slightly slower than people on Earth. They experience about 0.005 seconds less per 6 months than someone on Earth. We'll take the real-time scenario. Time dilation happened for Sunita Williams. Sunita Williams returned to Earth. Her onboard clock had ticked about 0.005 seconds less than clocks on the Earth. That means she aged slightly slower than someone on Earth. A tiny but measurable effect on Einstein's special relativity. Proof 3. The Haefel-Keating experiment. In 1971, two scientists decided to test Einstein like it was a spy movie. They took super accurate atomic clocks on commercial airplanes, one flying east, the other flying west, and flew them around the world. When they landed, atomic clocks flown around the world in airplanes showed slight time difference compared to the identical clocks on the ground, confirming time dilation due to motion. Just like Einstein predicted, moving through space literally changed how they moved through time. What does this all mean? Time is not just the background clock ticking the same for everyone. It is something you can stretch, bend, or slow down depending on your speed. The faster you go, slower time passes for you. And it is depending on gravity. The closer to heavy objects, slower the time moves. Your head is actually aging a tiny bit faster than your feet right now because the gravity is slightly weaker up here. This proves time really does behave like a dimension, just like length, width, and height. So, the fourth dimension in relativity is time, not a direction you can point to. It is real, measurable, and essential to how the universe works. Without considering it as a dimension, physics and modern technology like GPS would simply fail. That's why this interpretation of the fourth dimension is the most accepted and experimentally confirmed. So here is the big question I want to leave you with. Isaac Newton said gravity is a mysterious force that pulls two masses toward each other. But Einstein completely proved him wrong. He said there is no pulling force at all. Instead, a large mass bends the fabric of space-time and the objects simply move along those curves. Einstein's theory says the fourth dimension is time, and this has been proved again and again. But here comes the twist. What about the mathematician's view? Everyone accepts mathematics is the universal language of universe, yet mathematics is not saying that time is the fourth dimension. Moreover, string theory, Sage theory, quantum gravity, geometry, what are they all saying about this fourth dimension? So which one is correct? In the next video, we will explore all these fascinating views and challenges to come to a conclusion. Okay, if you enjoy this mind-bending trip into space-time, smash that like button, subscribe and hit the bell. Now I want to hear from you. Would you take a trip near black hole if it meant coming back years younger than everyone else? Drop your answers in the comments, because the next week we are diving deeper into black holes and wormholes.